These are similar problems to the front side of handout number 4. The first question asks us to graph this quadratic. So when I graph quadratics, I like to find out what the vertex is. And so the vertex can be a little bit tough here because we have a 1 as the b term. And so our little formula goes this way. Our x component of the vertex is negative b over 2a. So I take the b term, negative 1, and I take its opposite, so it becomes positive 1 over 2 times the a term, which is 1. So this is a right here. Our b term is the number out in front of x, and the c term is the constant. Well, we won't need the c term right now. So we end up with 1/2 as the x component of the vertex. So you end up having to substitute that back in for these x's here. And that'll give us our y component of the vertex. And so when I do that, I get 1/2, and I've got to square that, minus 1 times 1/2, and then I do minus 2. So 1/2 squared makes a 4th, and then minus 1/2, and then minus 2. Well, if you take 1/4 from 1/2, you end up at negative 1/4, and then minus 2 makes negative 2 and 1/4. So my vertex is going to end up being negative, or 1/2 comma negative 2 1/4. Either. So our vertex is 1/2 comma negative 2 1/4. So if you go a half space over, and then you go down 2 1/4, you'd end up right about there. And then from there, what you can do is you can use the parent graph. The parent graph works this way. If you've got y equals x squared, if you square 1, you're going to end up getting 1, whether you square a positive or a negative. And so that means 1 space over brings us up 1 space. We'll have a point here and 1 right here. And then you do that again. If you square 2, you end up at 4. And so if you go over 2 spaces, so 1, 2, you go up 4 spaces. So 1, 2, 3, 4. So you end up with a point here and a point exactly opposite of it, right about there. And so from that point, we can go ahead and draw that parabola, and we end up with this. And so what you'll end up noticing is where the x-intercepts are. And I want you to take a look at that, because there is another way. If you don't remember this little formula, you could end up coming up with a way to come up with that same graph. Now look at those x-intercepts. They're negative 1 and 2. And that's exactly what you get when you factor this. So if I was to factor this, it would factor to an x minus 2 and a x plus 1. And if I went ahead and solved, if I set them equal to 0, I'd end up with x equaling 2 and negative 1. And those are my two x-intercepts. Also notice that the y-intercept is at negative 2 at this point here. I know it opens up because it's a positive x squared. Well, that's what this one does. Now, when you don't have the b term, you see the b term equals 0 here. So my x component is in the 0 over 2 times by negative 1. Just makes 0. When you substitute 0 in there, you end up with just 1. See, 0 squared plus 1 makes 1. So you end up having that x-intercept, or that vertex, on the y-axis. And so here it is, just up 1 space. Now notice what the parent graph looks like. It's a y equals opposite of x squared. So when you square 1, you're going to take the opposite of that number, and you're always going to end up going down. So that's why over 1 brings you down 1 space. Over 2 spaces, you square it, you get 4, but then you take its opposite, and you always end up at negative 4. So over from the vertex, over 2, down 4 spaces. And then from that point, you can draw that little curve between those points. So that's graphing quadratics. Next question is a little bit different. Write an equation in factored form. Okay, remember, this is the factored form here. The x-intercepts are given to us, 4 and negative 3. So what that means is, notice what we had to do. We had to do an opposite operation to solve for the x-intercept. So when I look at this, if x is going to equal 4, I want to actually move that 4 back to the other side. So I end up having to subtract it. And see, that's why one of the factors is going to be x minus 4. The other one is x equals negative 3. Well, if I moved it back to the other side, I'd end up having to add the 3. And so I'd end up with an x plus 3. And so that would be my answer right there. There's the quadratic in the factored form. So a little different way of asking the same type of question. Write a quadratic function when graphed has roots of 2/3 and negative 1/2. So it's the same thing. So it's like x equals 2/3. Well, how'd they get that? Well, what they did first is they divided, well, in the last step is they divided by this 3, and so in order to get rid of that 3, I'd have to multiply by 3. So do the same thing on the other side. So I got 3x here. Now I have 3x equals 2, so I have to subtract the 2 from both sides. So that's one of the factors, 3x minus 2. The other one was negative 1/2. So how'd they get that? Well, x equals negative 1/2. What they do is just do an opposite operation. Multiply by 2, do the same thing on the other side. So 2x equals negative 1, then just add the 1 to both sides. And that's it. So the other factor is going to be 2x plus 1. Well, go ahead and multiply this stuff out, and you'd end up with a 6x squared. We'd end up with a 3x, a negative 4x for the inside terms. Last terms make negative 2. Go ahead and simplify a little bit. You end up with 6x squared minus x minus 2. So these would be the different answers that we could end up coming up with right there. Well, the next one is a projectile problem. An object is projected straight downward with an initial velocity of, and v, travels a distance s, and it equals vt plus 16t squared. So let's take a look at what we're supposed to do. And t is equal to time. If a rock is thrown straight downwards with an initial velocity of 10 feet per second from a height of 21 feet, how many seconds will the rock hit the ground? Well, the ground means s equals 0. So we're going to set s equal to 0 eventually. But what we want to do is substitute some of these things into our formula. So here, notice the initial velocity is v, it says right here. Initial velocity is v. So 10 has to go in place of v. And the height is 21 feet. So travels a distance s. Distance s. Well, it's got to travel that 21 feet. So 21 has to go way over here in place of that s right there. So let's go ahead and rewrite our equation. 21 equals 10t plus 16t squared. Now, notice that we want to hit the ground. Ground is going to eventually be 0. So that's what I'm going to do. I'm going to set this equal to 0. I'm going to move this 21 back to the other side. Now let's go ahead and rewrite it in a formula that's a little bit more familiar. 16t squared plus 10t minus 21 all equals 0. So what we can do from this point is try to factor it. And it will factor. Just might be a little bit tough. Now, notice that the outside and inside terms are multiplying to make, or subtracting to make 10. So I know they're pretty close. I'm pretty sure it's going to be a 7 and a 3. Now, since they need to subtract to make 10, I don't think it's going to be 16 and 1. I think it's going to be 2 and 8. We just need to figure out which way it goes. Now, it looks like if I put the 8 here and the 2 here, that might end up working. Let's check. So you see how these outside terms make 24t, and these make 14. Those will subtract to make 10. In order for it to make a positive 10, though, we need to make the 24 positive and the 14 negative. So that's going to be our formula the way it goes. So now we've got the factored form set up, so now we just have to take those factors and set them equal to 0. So we're going to end up with 2 different answers. So notice how we end up having to add the 7, and then we divide by the 8, and we get 7/8. The other one we have to subtract the 3, and then we divide by the 2, and we get negative 3 over 2. So we get 2 answers. Now, which one do we take? And how many seconds will it hit the ground? Well, we ignore the negative answer, and we go with the positive. So 7/8 of a second is our answer there. So notice that we're using that zero product property to solve. Well, these first 2 problems over here were asking us to do that in reverse. So similar type of problem, just asking us in a different way. Last one on this page, it says the base of a triangle is 2 less than double its height. The area is 56 square feet. What is the height of the triangle? Well, let's go ahead and draw a little formula, draw what's going on here. So the base, this is our base, equals 2 less than double its height. So taking 2 away from double the height. H is the height. Now this is the height of the triangle right here. So there's my right angle symbol, and this is H. And it tells us that the area equals 56. So let's write our formula down. 1/2 base times height equals, and then 56 is what our number is going to be. So what we want to do is we want to substitute. We want to take this expression right here, 2h minus 2, and we're going to put it in for b right there. So let's go ahead and rewrite our formula. It goes 56, which is the area, equals 1/2, and then times by, we got 2h minus 2, and then times by h. Well, let's go ahead and take half of these numbers first. Get rid of that 1/2. And so now what we've got is 56 equals h minus 1 times by h. So now let's go ahead and distribute that h over these two numbers. So now we got this, 56 equals h squared minus h. Well, this is a quadratic. Let's go ahead and solve it just like we did the one above, the projectile problem. Let's go ahead and subtract that 56 and set it equal to 0. And then what we can do is factor. So here's our problem. H squared minus h minus 56 equals 0. This factors as two binomials. H minus 8 and an h plus 7 are the two values there. So we end up with two answers. H equals either 8, because I have to add the 8, or negative 7. Now which one would you go with? Well, definitely not the negative 7, because we can't have a distance that's negative. So height is 8. Well, they want to know what is the height of the triangle. Well, there it is. Height equals 8. Now, let's say they want to know the base, just for seeing if we had to do something like that. What we would end up doing is just taking this 8 and putting it in for h, and that would give us our base. So this is our answer here, 8, and this would be in feet. But just for kicks, let's go ahead and substitute back in to find that base. So 2 times by 8, and then minus, 2 times by 8. Well, I already did that. Let's fix that real quick. So 2 times by 8, and then we have minus 2. So that makes 16 minus 2 would be 14. So 14 is the base, 14 feet, but they wanted the height. So height equals 8 feet. Well, that's the front side of that handout. Part 2 shows the back side.